Okay, very good. Okay, so this is going to just be a highlight of some Bash and Unix basic stuff. And then once I've gone through the slides, we'll do something live. There's a lot of stuff to be said about Unix and Shell. Please, at your leisure, take a course that's software carpentry. There's a link there. It's very good if you haven't had any of it before. So the goal for this session is basically to summarize some of the basic Bash skills that you'll need to do this course. We're not going to go into great detail. It will be very basic level. And then we're going to try some of these commands to explore your terminal so you know how to move around in the terminal as we start making directories and files and looking at files and so on. So this is what we hope to achieve during this little session. So you should be able to navigate your directory tree from the command line, understand what Unix redirection means, look at what's in the current directory, see what is the current directory, create files and delete directories from the command line, and then run a script from the command line, and hopefully maybe set and use some shell variables. We're not going to get into programming Bash at all, but just a little bit about variables. Okay, so Unix redirection. If you've never seen this before, this is a little bit cryptic. So most Unix programs will read from the terminal or the keyboard unless you tell it to do something else. And they also will write to the terminal unless you tell it to do something else. If you want to have results stored in a file, you have to actually tell it to do that by redirecting the output to some other location like a file. And you'll see these left arrows, right arrows, different flavors. They're called the redirection operators. And you should have these slides that I'm showing you here are available with a link from the GitHub page. You can follow along separately if you want, especially when I close these slides and start doing things on my terminal. You can always consult the slides on your own laptop. To move around, there's a few commands you need to know. We change directory with the cd command, change directory. If you're lost and want to know what directory you're in, you type print working directory, pwd. And just some examples of commands. If you type cd, you always go to the home directory, or you can specify a specific path. The tilde means home. So you can always start at the home / and then you go down a tree. We'll see how this works. So I'm just going through this a little fast now because I want to get to typing. But you can move up and down the directory tree, especially the cd ... is used to go back one step. And as I said, if you're lost, pwd will tell you where you are. Looking in the directory, there's a ls command for list. It will show you what files are in the current directory. And ls is the program like anything else. It has lots of options of what you will see and what kind of information about the files. And you see some example here. You can look for specific files. You can make a listing and save it to another file using a redirection to create a list of all the PDF files in my directory. Or I want to see the 10 most recent files. I do this all the time. What happened to my most recent files? I'll pipe the ls command -t for sorting time through head. And shows me the 10 most recent files. It's probably the one I'm looking for. Creating and destroying files in directory. So there is make dir, remove dir commands. mkdir makes the directory by the name you specify. And remove dir deletes it if it's empty. If it's not empty, you need to use a stronger medicine. So you have the remove command. Remove -f will forcefully remove a file or a bunch of files. And if you want to remove a directory with contents, files, and other subdirectories, you have to use the remove -r f for force to remove the whole directory. So a lot of power there, so be careful. It's very easy to remove everything if you're not very careful. Oops, I think we want to run your scripts. Okay, so we're gonna mostly run script using the bash command. So we'll do on the list 1 here, we will run your scripts by typing bash and the name of the script. The reason for that is that it gets into a lot of details in the weeds about making the script executable. Many of you already know this. You can make a script executable with change mod. But instead of going through this whole rigmarole each time, you're just going to run the scripts with the bash command. As you can see, there are a lot of ways to run your scripts in a Unix system, and it depends a little bit on your setup. So we're going to try to stick to the bash script. Very briefly on shell variables before we get into the terminal here. All the different shells have different syntax for how to set variables. So if you're coming from C shell or some other language, it looks different. In bash, it's pretty simple. You have a variable name, equal sign, and a value. No spaces between and around the equal signs. And you can use that to assign all kinds of variables. You can have a specific string, like here, 15C for 15 centimeters, maybe. It can be a variable that you can use in your script. You can use that variable to print things out, and you do that. You use the variable by prefacing with a $sign, and I like to put the name of the variable in curly brackets to make sure I know exactly what the name of the variable is. And we can also assign variables based on the output of commands. So here's a complicated one. I'm looking for all my PDF files sorted on date or time, and I only look at the first one by piping it through the head command and asking for the top one, and I assign that name to the variable last PDF. And maybe I'll print that out or something. So that's sort of the very, very highlights of things you might need to get through the day here with bash. I'm going to stop this sharing, and I'm going to start opening up my terminal. So I'll share. Let's see. Okay, share terminal. Sorry, I have too many things open. Where is code? Thank you. You should see a very dark screen right now, which is my Visual Studio Code. And I hope that you can, the font size are big enough for you to see. This is the largest font size you could use. So please nod, instructors, if you can actually see me typing here.
I thought you might want to make it a little bit bigger.
So how can I do this by scaling my window?
Yeah, same as a browser. Like Control Shift plus or Command Shift plus, I guess, for you.
Okay.
Yeah, that's good.
I think just changing the window size helped because I set that to the largest possible size. Yeah. Okay, so if you have a terminal, we'll start off by going to your home directory. So that will be type cd return. You are now at your home directory. Let's see what is there. You can do an ls command. And you'll see I have lots of files in my home directory. You may have nothing or lots of stuff too. All right, so just looking at my directory here, you can see I have oh, this is a messy. I haven't organized my directory very much. There's PNG files, there's PDF files, there's shell scripts, there's text file. It's just a mess. It's really hard to find. I want to see, what are my PDF files? I'm having this talk I have to give tomorrow. Where's my PDF files? Well, I can do ls star.pdf. Star is a wildcard, means anything that matches that position will go in there. And oh, there's my PDF files. So it's pretty easy to use ls to search for certain things. Which is the most recent PDF file? ls-t star.pdf. I'll sort them by time. So map.pdf seems to be the first one. I can pipe that through head. Yeah, map.pdf is the most recently made file. That's the one I was looking for. So ls is your friend. Where am I? Print working directory. That's always a lifesaver. Okay, I'm in users pwesel. That's my home directory. It will say something different from you, obviously, and depending on the operating system, it will say something very different. But that's where you are. I'm going to make a subdirectory, a folder for this course. And I want to do it on the command line. So I know you can do this from an Explorer or a Finder type tool, but it's always much faster to do it on the command line if you know how. So I can use the make dir command. I'm going to call this GMT course. I'll make that directory. Okay, how can I know that I did this? Is there something called GMT course in my listing here? Oh, I have too many things. ls GMT course. Oh, nothing. This is confusing. Well, I'm listing what's inside the GMT course, and there's nothing in it, of course. I need to go into that folder, cd GMT course. Now what? There's nothing there because I have just created an empty folder for the course. I'm going to create a file. Remember the 2 dots? The 2 dots means the parent directory. I can list the parent directory. And we saw this before, but now I'm doing it from the GMT course directory. So I have to specify I want to see what's above me. I'll create a file based on that. So I'm going to redirect the output from ls to a list.txt file. So I'm using redirection. I'm sending the output from the ls command to a file. Running ls again will now show me that I have a file in my directory called list.txt. What can I do with this one? I want to see the content of it. Well, I can put it in an editor. Okay, I can do that. I can open a file here. Open file. So now I can interact with my folder structure from the menu. And I will go back to my home directory and find GMT course somewhere alphabetically. GMT course. And there's my file, list.txt. Right, so a bigger font there. So there's my file. If I want to delete certain things here, I can, of course. I'll just delete a few lines and save it. The file is still there. I am getting tired of this file. I want to delete it. I'll do rm list.txt, remove list.txt. This is a little bit operating system and configuration dependent, but in my case, it will ask me, are you sure about this? Do you really want to remove that file? And yes, I'm sure. I typed the command, didn't I? So I want to delete it, so I'll type yes. If you're really sure that you want to delete files, here's the file again. I have my list.txt. I typically will say remove -f for force, list.txt. Then there will be no question, and it will do it. And you will typically do this in scripts if you want to delete files in scripts, because you won't necessarily be there to answer questions when you're running your script. So you want to make sure that, yes, I want to delete this file. It is gone. Setting variables. Okay, so we do that by variable name equals a value. Okay, so what about width equals 10c? Do I have a file? No, I don't have a file. I didn't create a file. I created a variable. How can I see the variable? Well, in Bash, we can print the variable with echo, and we have to put a $sign. If I just say echo width, if I get the width, if I forget the $sign, then it's just going to print the text width. It's not what I wanted. So I have to put the $sign in front, and I suggest you always put the curly brackets. They're not always necessary, but there are times when they are necessary, so might as well always do it. $curly brackets, name of the variable. It will print out the content of the variable. Now, for this course, we probably won't do too much of variables because it gets into details of programming Bash. But as you get better at these things, you'll find that having variables is really helpful. Imagining making a plot that should be 10 centimeter wide, and then later you change your mind to 12. Just having a variable that keeps that in one place for you to edit makes life very simple. Okay, I'll make a simple script that we can run. Okay, so in my editor, I'm going to create a new file. New file. Oops, new file. There. And we will repeat some of these things in the GMT basics, but when we write bash scripts, we should do the following. There's a magic line at the first line in the bash script that tells Unix that it should run this script with the bash language. This is called a shebang line, which is my t-shirt. So we'll start with a hashtag, which is a comment, the bang symbol, the exclamation, and the name of the shell that we want to use. Now, if you forget to put this in there, it's probably going to work if your current terminal shell is bash. It will guess that. But this is sort of making sure that this script will be run through the bash program. And I'm not going to do anything very fancy here. I'm going to assign a variable. I'm going to say plot name equal figure 10. So I assign a variable, and I'm going to print that out with echo. I'll put everything in quotes in echo. My figure name is $ curly bracket plot name. Just echoing that out. And then I'm going to do a ls. Oops. ls of my parent directory. And that's it. So that's my bash script. It's going to run, basically do 3 commands. The first one assigns the variable. The second prints a sentence. And the third one runs the program, the ls program, to see what's in my parent directory. And now I got to save that file. Save as. I'll call it minortest.sh. So I'll call all my scripts .sh for shell, even though you can use bash, but it's much longer. I save 2 characters by doing sh. So you'll see that Visual Studio Code now recognizes, oh, you're writing bash. I know that language. I can help you navigate your script by using colors to indicate what things look like. So now I have, well, let's see, do I have that script? If I do ls, there it is. I have a file called minortest in my directory. I want to run it, and I'm going to do that by running the bash command explicitly. So I'll say bash minortest. And one handy thing in the terminal is that if you start typing and it's unique, you can hit the tab key and it will complete what you're typing, if it's unique, right? If you have tons of files called m something, you have to type more than just m. But usually you can just type beginning of file, hit tab, it will complete it. Okay, so let's run that script. Okay, I got a listing. I got to scroll up here, see what happened. This is all the files in my home directory. Too many files. Go to the top here. Whoa, lots of files. Okay. There. Okay, so here is the beginning. I ran my script. The first command is the assignment of plot name. That doesn't show up because that's just run that command. So it assigns the variable name. There's nothing that's printed out there. And then I print out my sentence. My figure name is figure 10. And then you'll see the ls result of ls ... Everything is coming out at the end there. So if you're all following along on this, you have made most of the commands I talked about, not all of them. We haven't done piping and double redirecting. We can do double redirecting a little bit. So in my course, GMT course here, I have only one file. I can make a listing of everything in my directory to a new list.txt. I now have two files, of course, the list file and the script. If I want to see what's inside my list.txt, I can use either the more command, more list.txt. It's going to show me a page at a time because there's only one line. But you'll see that it lists what's inside the, sorry, it's two lines because there's the script and the list itself. And it goes to the end. So I have two entries on my list command. Now I want to append to that one using the double redirect. So I want to add the content of the result of the list command to my list.txt file. So this time I'm going to use a double redirect, and that means append. So very often you will build files that get bigger and bigger, and you do so by appending to them rather than a single one, which will delete what was there and start fresh. So I'm going to append ls to my list.txt. And now we're going to use another Unix command called cat, which is like print a file, concatenate list.txt. It should print what's in the list.txt file, and I expect it to have the original content and then repeat it because I appended the same command again. And that's what I got. I got list.txt, minor test.shell, and then it repeated because I appended the result. And if I keep repeating that command several times, it's going to just keep adding to it, right? So if I do cat now, I have multiple copies here. So you can append to the file. If you take out one of these redirects, it means you are deleting the file and starting fresh. So now I only have my two entries. So it is very easy to get confused about how many redirects do I have for what. In the beginning, you should expect to delete files that it didn't mean to delete, or append to files it didn't mean to append to, because it's easy to make that little mistake. So I think that is the highlight of Bash. Where am I? PWD. I am in my GMT course folder. I'm going to make one more subfolder of that, mkdir test. Now I see I have three things in my directory: the list file, the shell script, and a test directory. How can I tell that one is the directory? I can't tell. Well, ls has many options, and one that I use often is the -l for long. And if you do a long listing, you get one entry per line, and it will tell a little bit more about what the different things are. And you'll see, apart from who owns the file and what time it was created and all that stuff, size, how many bytes. The very cryptic stuff on the far left indicates permissions, that what you can do to these files. And you'll see the test one has a leading D for directory. So you can always do an ls -l and see that, oh yeah, those guys with the D are my directories. I can delete that directory, rmdir test, and it is now gone. So I'm back to square one with just those two files. And I don't really need those files. I won't delete them. Where am I? It's always good to know where you are before you start deleting things. Okay, I'm in my short course folder. I only have two files. I want to delete both of them. Remove star. There's a danger sign comes up. This is going to delete everything in your directory where you are. Well, you double check. Where am I? Okay, I'm in my GMT course folder. What's there? Just two files. I want to delete them. Okay, remove star. Okay, I didn't use -f, so it's going to ask me, do you really want to remove this file? Yes, yeah, that's just junk. How about this important scripts? Nah, it's up there, my editor. Now I'll close this and I'll delete it. Yes. And I'm completely empty. So that's where I started. So that was just very quickly a few things we're going to do as part of scripting and running commands today. So for any script you write, we'll just type bash space name of the script, and it will execute the script for you. So I think I'm out of time on this. If you have questions, please post to the Slack channel. You should have been able to follow along with this thing, I hope. That's all. The fonts are big enough you can see. And with that, I think we have a 15-minute break built in. We're about on schedule. So let's start again as is indicated in the schedule. So 5:50 UTC time, so that's in 10 minutes. Hope that's okay. We'll just shave 5 minutes off the break to get back on schedule. Okay, so we'll see you in 10 minutes, and we'll start on the GMT basics session.
Hi. So I'm going to just quickly show you how to open the Git bash shell and navigate to the directory where you are working, where you are saving the files and running them. So on Windows, that's how I do it, because really the quickest and the only one I remember, if you hit the button with the Windows key and you start typing and you start git bash, you should see git bash, or perhaps you need to type a bit more bash. So it's already there, and I hit enter and it opens, except that it opens on your home directory. So I do pwd and it's my home directory. It's G, like I was up to half an hour ago. So for example, in my case, I have the data in another directory, and I will do the cd. What I'm going to show you is the directory that I will work. For your cases, that you have to adapt for the directory that you need. So I'm going to cd. Mine is under v/unav go. So yes, ls, and I have the directory. So this bit is different for each one of you. I mean, the cd, you have to put after the cd the directory or directories, because you can do it all at once, or you can do it by parts. For example, I did it in two steps. cd dot to get parent directory, and then I moved to the other one. So if you have troubles with these, you can try to ask on the Slack channel. But well, basically that's what you have to do. Then you type bash and the name of the script, and this is the same as Paul has shown you. So please tell us if you have troubles in opening the Git bash. It should be also on Windows. You might, when you install it, you probably add an icon. So if you double click the icon, it will open this Git bash. Because I don't like to have many icons. I already have the double that I like in my screen. I always delete almost all the icons. I hate screens with many icons, but it's just my particular taste. So I don't have it on hand, but I know that on Windows it's very easy. You just hit the Windows key and you start typing the name of the program, and the programs come up. So I don't need the icons, but if you install it recently, you have the Git bash icon and you just double click, but then you have to do the steps of changing directory to your working directory. Well, on Windows, there are more easier ways. You can, if you open the file manager, where is go? No, go. I have it here. That's another very easy way on Windows. Is very easy, but not with bash, because you can copy the address and then paste, but then it does not like the backslashes. You have to turn it into slashes. So maybe it's not a good idea to show you many options. You just have to cd to the directory where you have your data. If you have troubles, ask us, and if you are not having troubles, we can help you easily.
Yeah,
Okay.
post questions in Slack if you have trouble with this. Thanks, Joachim. You want to unshare?
Oh, yeah.
Let's see. Okay.
I always have to find out to get out of this icon view.
Paul, you can share your screen and that should take over.
Yeah,
I'm doing
because I'm trying to make maximize where I have no option. Yeah, if you can do it faster than me, it's okay.
Change to basics. Sure. Should be okay. We're back.
Okay.
We're good.
Okay. So I'm going to start my timer here so I know how long I'm talking, because we have a strict schedule. Okay, very good. So I suggest you follow along in your browser with these slides, because they will go away eventually, right? And then, where are they? The links to that under the basics directory on GitHub. There are links to the slides. So there's a lot of stuff, and I can't go over everything, but for any module that we're going to be running, there's a full documentation on the genericmappingtools.org site, and I have a direct link here to the 6.1 documentation. This will give you a listing of all the modules, and you can click any of the modules to read about the specifics. And we'll do some of this together, but a lot of it will be on your own. There are GMT common options defaults. We'll mention this from time to time. There's direct links here, but basically the top one here will take you to the main documentation site. As I said during the introduction weeks ago, we'll be using GMT modern mode. So if you have used GMT a lot, but you use classic mode, it'll be a little bit different, but it will be worth it. And in this section, we're just going to focus on making a couple of location maps, starting from scratch. So there's no data needed. It's just the built-in coastline data. There's some basics that I have to lecture on a little bit about GMT. So GMT can make maps, and it can also process data. We're going to mostly focus on making maps in this workshop. And for any map, there's at least 2 selections that you have to make, and probably a third one. The first one is you have to specify a data region. So for maps, this means, part of the Earth that you want to display. For data sets, this just means the domain, the range of X and Y values. You have to specify that to GMT. It can't guess it. And then there's the projection, which turns that part of the Earth, which is round, as a ball-shaped thingy, we all live on it, into a flat representational piece of paper. All right, and there's lots of ways to do this, and these are called map projections. And we'll talk very briefly about them and use some, but there's a bunch of them. And then the third one is optional, but most of the time you want to draw a frame around your map so people can see what are the coordinates, where on the Earth are you, that sort of thing. So typically these 3 things go together to set things up. As for map projections, GMT supports something like 30-ish plus more through project through the proj library in Gedal. Very briefly, there's 3 broad classes of projections, and you can think of them like this. There's the azimuthal family. You take a piece of flat paper and put it on the Earth someplace, and then you project from the center of the Earth onto this paper in a variety of ways, and it gives you a plot centered at that tangent point. And then there's the conic projections, which you wrap a paper into a cone shape around the Earth, and you project from the center of the Earth onto this piece of paper, and then you unroll the paper. Again, many ways to actually do that projection from the center of the Earth. And then there's the cylindrical one, which is similar. You just wrap a paper around the Earth, and you can orient the cylinder in different ways, and that gives rise to different projections. And then you project from the center of the Earth through the Earth onto the paper in some fashion and unroll the paper. So those are the sort of the classic 3 types of projections, and then there's other, that we call them, which sort of show the entire Earth. And there's lots of those. They all have a lot of distortions, obviously, but we use them quite a bit to show the whole planet, the data sets on the whole planet. So we'll use some of these projections. Can't guarantee we'll use all of them, but they're there. Let's see, I did click. Oh, sure. Oh, it always does that. Sorry. Fine. The GMT modern mode script. So this is important. we're going to write GMT modern mode scripts. And inside the colored box, you'll see a template for what that looks like. We're going to start off with this bash setup. It's a little different here than what I showed you earlier. This is sort of super portable. It uses the environment program that everybody has to find the bash script. It's similar. I'll probably stick to what I showed you earlier when we start typing. Any GMT modern mode script starts with the command GMT begin, and it ends with GMT end. Both of those have some options. Anything in brackets, as you see here, or in the man pages, means optional. And if you use them, you don't type the brackets, just what's inside the brackets. So you can specify the name of the session, often the file name or the plot name, and what kind of format do you want to create? Is this a PDF, or do you want to make a PNG, or maybe many types? And then between begin and end, you have all the GMT and Unix commands you need to make that session work. And then you do GMT end, and you'll see we're going to use GMT end show quite a bit, which means the plot or plots, if there are any, will be opened up for you to look at right away as the script runs. So that's sort of what a GMT modern script looks like. So we're going to start off by making a map of Italy. And the steps we're going to do this together. We're going to switch out of this Google Docs, Google Slides here shortly. But we're going to start a new script in the editor. And we're going to make a map of Italy. So we kind of need to know where the region, what's the region of Italy? What's the longitude and latitudes? Or do we? So we'll see how we do that. And we have to specify a map projection. I said we got to specify the projection and the region, or do we? And then we're going to plot Italy. So presumably there's a coastline database behind there somewhere. We can draw the outline, or we can paint it. Then there's the question about, do we draw a frame around our plot so we can see where we are? And do we annotate? And what do we annotate? How do we specify that? Or do we have to? And then we're going to run the script. And if we have no errors, and often we have errors, but if we have no errors, we'll have a script plot up, and then we'll say, oh, well, that's not what I wanted. We're going to have to make some changes. And typically, you'll change the script, run it again until you are happy with the results. So that's the usual recipe. So I'm going to stop this presentation here and move into my Visual Studio Code. Share. So you should now see my very dark screen. And I am still in my GMT course folder. Okay, so we're going to work on a script together to make a plot of Italy. And I need to open a new blank file in my editor. So there's many ways to do this. There's certainly a new file, or just a shortcut, Control-N or Command-N. So here it opens up a new untitled file. So I'm going to start off by saying hash bang /bin/bash, right? Remember, that's the command line to tell bash that this is indeed a bash script. And I'm going to save this file right away so it has a name. Save as. For the save as command, I'm going to call this Italy. If I can spell Italy, that's hard. E-A-T-A-L-Y. Good. .sh. Save. Okay. So I have a file.
Paul?
Yep.
Sorry to interrupt. Just so you know, when you click on the menus, we can't see that on the screen share. Since you're only sharing the application window, the menus don't show up.
Okay, thanks. So I'll try not to use the menus up there, shortcuts. Okay, so if you follow this far along, you'll see you have a file with a one line in it. And it is the shebang line, the line that tells us to run bash. Now, in a shell script, any line that starts with the hashtag is a comment. So it is a good practice for you to add some comments as to what the script is supposed to do, so that you can later read it and say, oh yeah, that's what it's doing. So I'm going to just type in here, making a map of Italy. I can have as many lines as these as I want anywhere after the first line. Okay, so that's the purpose of this script, to make a map of Italy. We're going to write a GMT modern mode script, so we have to start with GMT begin. And the optional arguments are, what's the name of the session, which is the name of the plot if you're making a plot, and we are making a plot. I might as well call that plot Italy. And optionally, I can specify what kind of format should this plot be. You know, should it be a PDF, a PostScript, PNG, JPEG, so on. If I don't give anything, the default is PDF. So I'll start with that. Just GMT begin Italy. It sets that up. Now, there's no specific requirements that you have an indent inside the GMT begin. It's not like a Python thing where you open up and you have to go in, but I like to put a couple of, I like to do a tab inside the GMT begin to sort of organize my script there, but you don't have to. And the command I'm going to use to make the plot is called coast. Now, to really look at all the options that coast offers, you would have to go to the man page, the module page for coast. And you should have that shortcut handy. I'm just going to use some of the options on coast today, so we don't have to go and look at them, but that's where you would find all the details. So I will start on my GMT coast command. And you remember you were asked to specify the region. You have to specify, what are you plotting? What is the region on the Earth? Well, Italy, I know sort of roughly where Italy is, but I don't remember the coordinates of Italy. Who knows? It's Mediterranean. It's probably in the low single-digit longitude and in the, what, 30s, 40s, maybe in latitude. It's too hard. So I'm going to use the -r option, which in GMT specifies what is the min-max boundary. But for making plots of countries and continents, I can use the shortcut, the 2-character ISO code for the country. So that is IT for Italy. So I'm going to use Italy as the domain. And I have to specify what kind of plot do I want. And I'm going to paint the land a certain color. How do I paint land a color? Well, I specify -G, and I give it a color name or a red, green, blue combination. And in my case, I'm just going to use the color, let's see, green. That's easy. -green. And projection, I don't know yet. I haven't decided about projection, so I will leave that to GMT to pick projection for me. But I want to see a frame around the map. And that is the long-hated -B option. And B is for the base map frame. It has lots of options, but I'll let GMT figure out some sensible defaults. And that's it. So I am almost done. I have a GMT begin. I need to have a GMT end and then show. So GMT end, show, return. And I want to save that. Save. And that is my script. So how are we doing? Is any major concerns in the Slack about doing this? No, you have to spell the color command. Sorry, Leo, what to say?
Just saying that so far so good.
Okay, yeah. So there's a question about, can you shorten the name for colors? No, if you give name of the colors, they have to be exactly like they are, because there's tons of greens, there's tons of blues and flavors. There's a web page, if you go to the GMT documentation, that talks about all the color names. There's, 600 or something like that, color names that GMT knows. But think of the basic colors that you know. You can use all of those, and you can preface them with things like light or dark. So you can say dark green or light blue or something. So all those things will work. And then there's crazy names like, salmon red and Indian blue and whatnot that you have to look up. but there's more to say about colors that we'll talk about later. Okay, so I have my script. I saved it. Where am I? I'm still in my course directory. Do I have any files there? Yes, I have the Italy script. Okay, so I'm looking at my code here. I think I got it all right. I'm going to try to run it with bash italy.sh. Moment of truth. Okay. Okay, so maybe I should share my entire desktop so we can see plots. Would that be good, Leo, do you think?
Yes, please. I was going to comment on that now.
Okay, we'll share my desktop. I'm only concerned that I have a very large, things will get small. Let's see, okay. Can you see my desktop?
You might want to mute Slack as well.
Yeah, well, okay. Where do we mute Slack?
Maybe just turn it off.
Okay, I can turn it off for now. Since I'm not gonna answer it. Okay, is this visible to people when I share my whole screen? Are the fonts too small, or can we see things?
Yeah, I can see it.
Okay, good.
Just
So you can see I got a plot here. I got a plot here of Italy. It's very green. And you should too. If you ran the commands that I showed you here, you should have this plot on your screen. This is very similar to the homework test, right? Where you ran a test and a map popped up. So if you have no typos or mistakes in your script, then this should work fine. Okay. So, okay, we got Italy. I can see the coordinates now. It goes from 8 to 18 or something, and 36 to 46. Okay. All right. I'm gonna make some changes to my coast command. So it turns out I don't really like the green color. It looks weird to me. Okay, so I'm gonna change green to another color, which you wouldn't guess. It's called wheat. It's a color called wheat. And I'm going to add an outline pen. So instead of just painting the land, I'm going to draw an outline. And that is usually set with a -W for pen width. And I'm going to say thin. Draw the outline with a thin pen with wheat. And now I'm going to actually, well, I'll do that first. I'm just going to save this. So save that file and run it again. I use the up arrow to bring up the past commands, save me typing, and I run Italy again. Okay, so more or less the same map comes up. The color is now different, more brownish, and I have a line outside the land masses. Okay, that's pretty reasonable. But I'm not specifying, yeah.
Paul, may I interrupt for Windows users?
Sure.
Sorry. You are using default PDF. If you do what you did on Windows and the file is open, you'll get an error because the file is open and it will let you update. That will not happen if you use PNG. It will just open a next one. So Windows users, I don't know others, but Windows users will probably get an error if they repeat what you did because of the PDF. It's open.
That's a good point. So that's a good time to segue into other formats, right? So as you remember, the GMT begin line not only sets the name of the plot or the session, you can also specify the type of formats of the plot. So we're going to switch from the default PDF to PNG. I'm going to make PNG files. I'll just save that and see what that looks like when I run it. And depending on what your viewers are, it will open up in maybe another viewer. So now here's italy.png open up on my computer. And on Windows, that should also happen fine and open up the next version, not to give you any errors. Okay, so that worked good. I haven't specified any map projection. And what GMT did was to give me sort of a basic longitude latitude projection here, which is not truly, is nothing. It's not the equal area, it's not conformal, anything. It's just long lat. So I'm going to use the most favored map projection of all geophysics, and that is the Mercator one, because it's so easy to remember and to do, and it's abused everywhere. So with projections, we use the -J command. And again, there's 30 odd projections with all kinds of parameters. We're going to use the Mercator a lot because it's simple, but we will talk about other ones too. The next letter is capital M for Mercator. And the capital letter has a meaning. It means that the dimensions of the plot will be given in the width of the plot. A lowercase m would give you a scale, number of centimeters per degree or something. But I want to have a plot that has a certain size, and I will give it 15 centimeters. So a Mercator map that is 15 centimeter wide. I don't know how high it will be because that depends on the region and the projection, but the plot will be 15 centimeter wide. I will save that and run my bash script again. And hit return, even better. Okay, so now it changed. It got much more elongated because the projection is kicking in, and it looks like Italy. What else can I do here? Well, I want to show the national boundaries. So I can see, this is Italy is part of Europe here, but there's no obvious boundaries here. So we have political boundaries. I'm going to add one with -n. And there's several levels of boundaries. There's the country boundaries, and then there's some internal boundaries in some countries, but not all. And then there's maritime boundaries. I'm going to select option 1, N1, which is the internal, which is the political boundaries between countries, and specify a pen. I'm going to have a thick pen, comma red. So red thick pen will be my boundary line. I'll save that and run it again. And now I have the map boundaries. Okay, so I have a map of Italy. The region was determined automatically by the Italy country code, and it's kind of tight. You can see that the western boundary is right against the western extent of that red boundary there. Same thing with east, north, and south. So I want to give it a little bit more space, and I can do this in a couple of ways. I'll do the simple one first. I'm going to say use the Italy boundary, but round the coordinates to the nearest multiple of, let's say, 2 degrees. So whatever the western boundary, which might be 6.35 degrees or something, it's going to be rounded to a multiple of 2 in all directions. Sorry, plus R2, round 2. If I run that, it will change the region. You can see there's more space around Italy now because everything is in multiples of 2. And you can see this from the annotations that they now start at 6 through 20 and 34 through 48. And if I want to tinker more with this, I could replace my Italy country code here with the actual coordinates. So often we will do this. And here I will say, well, how about go from 5 degrees to 20 in longitude, and from 30, I think I can go to 36 to 48 in latitude. So west, east, south, north is how you specify this. So in a kind of x min, x max, y min, y max situation. And I'll run this again, and it just changes a little bit. So this is a pretty reasonable map of this area. I call it Italy, but there's nothing special about Italy here. All the countries in that area is now shown. So I want to highlight Italy. I want to paint Italy a different color than everything else. So the way I can do this in GMT, and I'm going to add this to my coast command. I'm going to break this coast command into 2 lines in my terminal here, in my monitor, because it's too long. So I'll put a backslash at the end of that line and immediately hit return. That basically extends that line as far as the Unix bash sees. That's one long line. So I'm going to keep adding to my coast command. And what I'm going to do is I'm going to specify a particular country, in this case Italy, and it should have a different color. And the way to do this is to use the -E option. Again, I'm throwing these options at you because I don't have time to walk you through all the documentation for each module. But if you look at the coast module in documentation, you'll see that it has lots of options that are carefully explained what each of them does. It's just a little bit time consuming to go through it. So -E will let me choose a country code. I'm going to use Italy. Again, this will pick Italy from the coast base, and I'm going to do something to it. In this case, I want to paint it red. So I'm going to use a modifier plus lowercase g this time, and I'm going to type red. So it reads a little funny, plus gred, but it's plus g and then red. So this will make the same map, except Italy will also be painted red. So I'll run my bash command. And there you go. So we can single out countries and even groups of countries. If you read the E, if you're interested in this, you can read about the E option, and you can see how you can paint continents or clusters of lands, countries, and how you can give them different colors and so on. But this is sort of gives you the highlight of what Coast can do. We're going to do a couple of little bit fancier things. So in general, this is a pretty reasonable plot. Anything you see here can be tinkered with. You can be fussy about the border pen, and you can change the pen, and you can be fussy about the frame. You can say, I don't want to annotate every 5 degrees. I want it differently. You can change that with the -B option. You can say, I don't want annotations on the right side of the map. Well, you can change that. There's an infinite number of configurations that you can do, and don't have time to cover all that stuff. But the documentation talks about all of those things. Finally, here, just since we're on the GMT begin name of the file and the plot, I could, like Joachim mentioned that in a PDF was complicated. I could actually say I want a PNG and a PDF. I can just list several formats in that place, comma separated. I can even make a JPEG, right? If I wanted to make these different flavors. Now, usually you don't need that many different kinds, but often you might want a PNG or a JPEG for a web page, and then a PDF for a publication or a print or something. So you can choose how you do this. In my case, I'm just going to run this to make sure, in fact, I get 2 plots. And they both should open up. There it is. The previous plot was there, and here's my PDF in my PDF viewer. And I can zoom in on that one, and it's a vector graphic. So, zoom in all the way here. Okay, so are you with me so far, folks? Is it working? All right. We're going to make a little, let's see how we're doing with time here. Okay. We'll make a little twist here. So GMT6 has a new thing called a map inset. We can place a little map within a map. And I will come back to I'm just going to show you how you would do this in this script. Let's say I want to plot a little world map up in the corner of this area here to show where Italy is in the world map, in case you don't know where Italy is. You would use GMT inset, and it has some options. And then you would do another GMT coast. I'm not going to run this. This is not commands that will work. You'll run another global plot in the corner, and you will say GMT inset end. So inset begin and end. And I'll come back to this little sequence of commands a little bit later, depending on time here. But I can insert a little plot in the top corner, top right corner of my my screen there. But I'll keep that. I'm going to comment this out. So to comment this out, I'll just put a comment symbol in front of it so that I don't ruin my script. I'll have that for later. I'll take off the PDF again, just back to PNG. And you know, these commented out comments are not causing any trouble. Right, it still works pretty well. Okay, so we'll leave the Italy plot behind for now. You will be revisiting that in the breakouts for tasks, but for now we'll leave that behind and start a new script. All right, so I'm going to start a new file here, and I'm going to start it with the same hashtag bang/bin bash. And this task is going to be try the figure command. And I will save this to world.s. I'm going to make some world maps. Okay, so I have a new file, world.sh. And I will want to make a plot of the entire planet. And I'll first start the same way I did before. So it's going to be GMT begin. And I can say I'm going to call this world. And it's going to be PNG. And what do we know so far? Well, we know the GMT coast command. So we'll stick with that, GMT coast. Now we're going to make a world map. Okay, so how do I specify the region of the world? Well, you know, if you know something about coordinates, you know it goes from 0 to 360 or -180 to +180 in longitude and -90 to +90 in latitude. That will work. You can specify that as your west, east, south, north boundary. But we have a shortcut for that in GMT called, there's actually several, but I'm going to use G for globe. So R lowercase g means the entire planet. Okay, so for a planet, I can't really use the Mercator projection because you might remember that cylinder paper is not going to project really well for the pole up because that line will be parallel to the paper and it will infinitely tall plot. So we can't do that. We're going to use one of those other projections, -J, that are suitable for global maps. And there's a whole slew of them in GMT. If you read the cookbook, I suggest you should read the cookbook about projections at one point in your life. And this is a perfect time in your life because what are you doing? You're stuck at home. Might as well read GMT documentation. So the hammer projection, capital H for hammer, it takes two arguments. One is the central longitude. I'm going to say 0. And the second argument is, what's your map width? Well, I'm going to stick with my 15 centimeters for now. And color or line, or what do we want to do? I'm going to paint the lands. You know, it is early in Hawaii. I'll use a horrible color that I won't last. It's going to be purple. I mean, who would plot land purple? Purple. Can't even spell it. Can't even spell it. Oh, there it is. Purple. I'm going to paint the purple. And I'm going to draw the outline, but I'm just going to draw the grid lines so we can see where things are. And that's it. Oops, come on, computer. GMT end show. Save. Okay, so it's not, we haven't tried the figure command yet. I know, we'll get there. But this is sort of what we've done so far. We know how to do GMT begin, plot name, plot type. We know how to do a GMT coast. We have the region, the whole world. We have a projection now, the hammer projection. we have a hideous color, purple, and we're going to draw the grid lines, and it's going to show. So I'll close this italyplot, and now run bash, what do I call it? world.sh. Oh, that's hideous. Now, if you agree with me that you think this is a hideous color, you should change that purple in your editor. Please, just change that color to some other color, right? I mean, I will do it too. This is painful. Purple, who thought of this? How about anything is better. Even wheat is better. I'm gonna do a orange. Orange, save that. Surely better than purple. Yes, way better than purple. Okay, so we know how to make a map. It's just basically a PS coast job, with the region, projection, the boundary. Here we drew the grid lines. You see, it's a lot of grid lines. What if I don't want that many grid lines? Well, you got to look at the -B option to change that. This is the default. Default depends on this projection and the size of the plot and many things, and it's usually pretty good. Okay, how about the figure command? All right, so a GMT session, which is started by GMT begin, can make many figures. It doesn't have to be one, but very often it's like one. You make one GMT script to make one figure. But here I'm going to make a couple of figures, and I will want to do it within the same session. So to do that, I have to use the GMT figure command. And the figure command is kind of like the begin command in that it sets a name of a plot and what kind of format. So before this GMT coast, I'm going to call GMT figure, and I'm going to name this plot. I'll call it world 1, and it's going to be a PNG. And because I'm specifying the name here, I don't really want to do it up there. It don't hurt, but it won't be used because I'm already specifying it here. So when the GMT figure command comes, it sets the name of the plot that we are about to make and the type, and that stays in effect until you issue another figure command. So just for now, I'm just going to save this and make sure nothing broke. All I'm doing is basically changing the name of the plot to world1.png. And you see I got another window up now with world 1. I'll close the old guy. It's the same plot. But now we're going to use the power of the old cut and paste. Cut and paste is a two-edged sword. It saves you a lot of typing. It also introduces you to potential errors. But we're all, limited in time. So I'm going to do a copy and paste of that command to have two identical commands. So that's just duplication. Because I don't want to run exactly the same command, I'm going to change the second figure call here to be called world 2. So I'm going to have two worlds. And then I'm going to change the projection for the second plot and probably the color. Orange is a hideous color. How about purple? That's much better. So do a purple on that one. And for the projection, let's see. We have a lot of projections. I'm going to try the Robinson projection. And the good thing about all these global projections, they're all very similar. They take a different letter, of course, for the projection, but then they have the same central longitude and width. So capital JR will do the Robinson projection. And now we have two commands. We have two GMT figures being produced by this single GMT session. I'll save that, and I'll run it again. Okay, so now I got two plots. I got the first one, world 1, hammer projection. Looks like a ellipse. The pole is a point up here. And then we have this beautiful Robinson projection with a nice, delicate purple color. And here you can see that the North Pole is actually a line. So it's incredible map distortion at the pole, since a point is now represented by a line. Same thing with the South. But this projection is used quite a bit by National Geographic, among others, to show the entire planet with sort of a compromise of distortion. Right. This one here is actually equal area. So the area here is truthful, but the shapes of things get a little funny towards the pole points. everything looks pretty good around the equator. So this is a way for you to make many related figures, separate figures, but related in a single GMT session. You just use GMT figure to set the focus into a new figure, and then whatever you plot after that will be part of figure world 1 in this case until your next figure. Now, most folks will do it this way. They will write the figure, and then they will finish the plotting of that figure, and they will move to figure 2. You don't have to. You can switch back and forth between figures 1 and 2 by calling another GMT figure world 1 later down here. It makes your script a little bit more cryptic, but you can do it. But I like to keep things organized like this, and I'll probably would put in some comments here. Make hammer map of the Earth here, and then down here I would say make Robinson map of the Earth, so that it's more clear to someone who's just looking at this script. And also, you know, years from now, I might want to find that script that I knew I wrote during this workshop. I can't remember the name of the script or where it is, but I know it has the word Robinson map in it. And I can use the computer to search all my files for one file, a script that has that word in it. I will find it instead of starting from scratch. So putting comments in is very helpful. It's easier to remember comments and context than specific GMT commands. Okay, so happy with that. Everybody got the beautiful purple map and orange map up there. That's good colors. I'm going to show you one more thing before we give you tasks to do by yourself, and that is a subplot. So a subplot is when you want to make more than one figure, but it should be part of the same figure. So it'll be like panels of a single figure. So I'll start a new script for that. And I have to start with my shebang call again, hash bang slash bin slash bash. I got to read my t-shirt. Yes, I got it right. Introduce subplot. And we'll save this to worlds plural.sh. Save. And now we're going to try to lay out a plot of several worlds on a sort of a matrix layout. Okay, so we start off with what we know, which is how to start a GMT session. GMT begin. I can make a single plot this time, so I'll call it here worlds. I'm going to make a JPEG. And then, of course, I'm going to end with GMT end show. So this much is known. We know this part already. You have to have these opening and close commands. But now we're going to look at subplot. And subplot has several modes. We can start a new subplot. We can move the focus into a particular panel. So plotting will happen there. And then we can end the subplot. So we're going to start with something called GMT subplot, which is a new GMT module in GMT 5 was introduced. And then we're going to begin it. We're going to begin a subplot. And begin takes several arguments. I'll try to keep it super simple here. It's going to take, what's the layout? Well, I want 3 rows by 1 column. So there's going to be 3 plots, one on top, one below the other, 3 by 1. And I will set up the size here to be, for the whole collection of plots, to be 16 centimeters by 25 centimeters tall. Excuse me. So that's my whole page of plots. And I want to label each of the panels A, B, C with the -A option. And then when I'm done with my subplots, I have to turn them off. GMT subplot end. Okay. So in between here, we're going to actually write the plotting commands and move from panel to panel. So this is a relatively simple example of how we do this. You can make it more complicated. You'll have to read the subplot manual, look at some of the examples for some of the more tricky things. But here I'm going to start the first plot. I'm going to make same maps as you've seen over here, these global maps. I'm going to make 3 of those in this format. So it's GMT coast, which you know already. GMT coast, region, well, it's the world, RG. Color, well, we'll start with, how about red? Now let's be adventurous. Let's say we can give red, green, blue color combinations. So I'm going to give it between 0 and 255. I'm going to say, how about 35 red, 100 green, and 88 blue. I don't know what color that is, but we'll find out. And then we're going to draw the grid lines, BG. Okay, that's my command. Where does it go? Well, by default, it will go into the first panel. So I will let that happen. And now I want to do my second one. Okay, that's not a GMT coast command. GMT coast, you can copy and paste if you want and edit, but I'm just going to type it in. It's short enough. Minus RG minus G. Got to have one purple, at least one purple plot in this one, and minus BG. But now I want to move to the second panel. So I'm going to do this the simplest way I know how, which is with the minus lowercase c option. It just advances to the next panel. So the first one started automatically in the first panel. Minus c means go to the next panel and plot there until you go to another panel. So, okay, that's easy. Now it's in the second panel. And now I'm going to get lazy again and do a copy and paste. I know I shouldn't be doing this, but old people are slow. They have to copy and paste a lot. And so it's a lot of similar things, but we don't want to do 2 purple plots. We want to do a light gray one, maybe. Could be nice. And maybe we should be bold and paint the ocean in this one. How about minus S for the ocean side? I'll call that light blue. And minus BG, yes, draw grid lines. Minus lowercase c, move to the third panel. I'll save that. I'll close these other plots from before. And there we are. So I'm going to run this. Bash worlds.sh. So what I expect here is to get 1 plot, but 3 panels, ABC, with 3 global maps. And I've forgotten map projections completely. So before I run this, I realized, oh, I should need projections here. So the first one, I'll make that a hammer map. Oh, what's the map width? Gee, I don't really know. I have a page that is 16 centimeter by 25 centimeter, but it's going to be split into 3 with margins. And I don't know what that's going to be. So in subplots, you're allowed to not know the dimensions. And you put a question mark, because it has to be calculated from the dimensions of the subplot and all the other things that you can't really be expected to find. So I'm going to give it a question mark for the width. For the second plot, I'm going to do a Robinson projection. Same thing, 0 question mark. And then for the third one, minus J, Winkle maybe? Winkle plot. Same thing with a question mark. Actually, that's a mole wide, I think. Can't remember. All right, so I have 3 projections, but I'm missing the size parameter because it's an unknown. I put a question mark. Now I can try to run my script. Oops, I had a fail. This is great. I got an error message. I got some plots, but I got error. Light gray, not recognized. Oh, come on. You know what I meant. I want light gray. Gee, I have to spell it out. Yes, light gray. So like I did light blue. So computers are unforgivingly stupid, right? It's not going to fix this for you. So you got a nasty error message and you have to figure out where it is. But at least this line here was very helpful to me. I can see right away that I did a misspelling. So I'll try it again. Okay, wow, it's a very big map. I got to shrink it down here. Okay, so you see my page here. This is the 15 by 25 centimeter plot. It has 3 maps on it. They're labeled automatically A, B, C. You can change all that stuff with the -A option. And they all fit in their panels thanks to the automatic scaling through the question mark. You can see they're all sort of different dimensions, either in X and Y, because of the way the projections work. So that all pretty good. So with those 3 examples, what I want you to do in the breakout room is to try the following. So go back to Italy. You should make a map of your home country in a similar fashion. You'll have to work out what's the -R option for your country, what's the 2-digit ISO code for your country. You should know these things. If not, you can Google them. And make a map of your country. And then we didn't have time to really talk about the inset, but you could look at that, how to place an inset. And the other task is to change this plot of 3 worlds into a 2x2 plot where you have 4 in a matrix 2x2 layout. So that's how we're going to do for the breakouts. You're going to work on those 2 tasks. And you can use these examples as templates or start from scratch if you want, but you have some of the things there to play with. Okay, so I'm going to stop this screen share here for now. And go back to my, here's my desk. Actually, I could go back to the desktop. Sorry, I have my whole desktop here. I didn't really follow my slides here, which is fine. It just talks about what we did, basically. Although we didn't do Russia and USA, we made global maps. But this was just to get us started. So Melissa, you can break people into breakout groups, and they can work on their own country scripts. And if there's time, you can work on a 2x2 map of global plots with different colors and all that.
Okay, think so. How many are we all? 6? No, that's the shot. Okay, 65. A lot of people. So okay, I'll ask you that if you can open the GitHub page with this section topic, the lines and symbols. Well, I'm sharing my screen, so we're gonna follow just this page here in GitHub. And I'm going to talk to you about how to draw lines, plot symbols, change sizes, and many aspects of the things you can do in GMT to plot lines and symbols. So, and also polygon filling, painting with colors and patterns and things like that. So it's not so, the figures are not so nice as we have seen before. It's always nice to see global maps. We then plot our own countries. We're gonna have something a bit more, well, less spectacular, but also very useful when we want to make plots. So we're gonna do some of these. I don't think we have time to go to the details of all of the lines and the next ones, because it's only a 50 minutes session, and we want you to have time to do some of these by yourselves. So please open the videos, your editor, and start I'm on Windows, so start the Git bash window. I'm gonna do it. I showed you before. So I will change directly to where I have the data, and I wanna save the scripts. This/nav2. So this it will be this for me. And okay, let's start. Well, I made a little tricks that I copied already some instructions. I simply do not remember these numbers by heart, so I can type them here. So you have another script with all of that. But let's start with just a plain line red line. So like the examples before, we type the bank line. By the way, Paul did not use the USR, but you can either have it or not have it. It will work both ways. So type the line, also the example, the comment with what we are going to put in this script, which will be plotting lines with different settings, styles and whatever. So lines, okay, no, I will change mine because otherwise I will delete the one I have. So start by typing this echo 00 superior to a name of a file. What you are doing in these two lines, you're just creating a line, so you don't need to have a line to work with. We're going to generate one with just 2 points, straight line. So it's going to be a line that goes from origin 00 to a point 10, 11, slightly slanted line. And we do like we saw Paul showing in the Unix basics. We create the file that will have the temporary. This is a common name that we use, t.date, and we append to it. So with these two lines, we generate a line, the coordinates of the line, and then we're going to plot it. Okay, because I'm going to use the more lines, I preset a region that goes from -1 to 11 in X and -1 to 11 in Y. So it's a square. And we're going to use, no, we are not going to use projections here. We could have used projections, but it's simpler. We're just going to use the linear projection. Linear projections are specified with a capital X. And then we say to plot the axis, annotate in frames and ticks, and also to annotate on the left and on the southern side. And then we're gonna, okay, adding some more details. We're gonna make that line 1 point thick and the color red. Okay, you could not have specified the P by default. If you don't say the units, it assumes that there are points, but to be clear, we put the P line here. And we say that's 1 point thick and the line is red. So we save the script. Well, by the way, I always save the scripts by typing Ctrl+S, which on Mac will be Command S. So you can go to File Save, the quickest ways with the keyboard, and I say, and I hit Ctrl+S, and then I save the file. So
hey, Joachim, can you make the font slightly bigger? Someone that can't quite see. Is that possible?
Okay, yeah. Well, they should not be very large, the scripts. So I have that script that I call it lines tmp.sh. Must have it here. ls star.sh. Here it is. Line stuff. So I do bash. Double click. Okay, I can type it. We have those habits. You can also double click and then right click and copy the name. But if you start typing lines, then you get that. And we get the not very exciting, just a plain line in red. If we want to do more things, for example, do the line, add another line, but I will copy these ones and then I'll have also my notes. because it's not. Now I'm going to generate another line, and I think it's. I have to confirm. Lines. This one. So yeah, 10, 2, and then I'm going to use the 3 green. So, oops, where is it? Here. What? 10, 2, no. 10. I'm increasing the y, not the x. And then, oh, 2. And then I don't need to repeat the r anymore. I don't need to repeat the projection anymore. I don't need to repeat the axis anymore, because all of these were set on the previous command. So we don't need to repeat them anymore. That's another advantage of the model node. So once you set these parameters, you don't need to repeat them on the next pulse. So if I want to do it 3 green, on everything in green. Oh, yeah. I'm showing now on the GitHub, you'll get this line. So you don't need to repeat this. Please get more. Oops, where did the page go? Oh. Oops. I maximize the page. So let's run it. It's quicker than walk. And then, oh, okay. I made some mistake in the coordinates. Doesn't matter. So you have a line which is 3 times thicker because it said that we wanted to have 3 points thickness, but it's still a continuous line. So next we're going to make a dashed line, like this blue line. Dashed line, we have to tell it that is dashed. So we do and copy, paste, and it's going to be coordinates is going to be 10, 12, 10, 0, 1, 0, 2, 10, 3. 0, 2, and 3. And the line is going to be blue. But also, we're going to say it's a dash line. Right? Just verify. Dash it. I think it accepts both dash and dash it. Remember, but to make it safe, so make it different, or make it dash, you add these. If you don't add the type, it will be a continuous line. So, here. Run the script, and here you have the dash line. I don't want it. Okay. The same way we can do it dash it, we can also do it dot. If you say dot, you will get a dotted line. And also you can do a line is dash dot. And so forth. These things are documented and are a bit boring. I'm not going to spend much longer time with it. So the green one will be fine. We'll jump to that one, green. This one. But to do dash dots, or either we can type it. I'm going to jump to this one. I'm not sure here. So here, someone asked it on the slash on the slash if we could give the colors by the components. Yes, you can give colors by names, or you can just give the colors by component. Here we are using that facility, and we are specifying the color as 0 red, 150 green, and 0 blue. And these minus and dots means do a slash dotted line.
Hi, Joaquin. Sorry to interrupt, but your sound is breaking a little bit. So could you turn off your video? And maybe
turn off the video.
better?
Oh, The sound is breaking. That's
Yeah,
disappear.
there you go. Let's see if that works better now.
I don't see things because we change here at home the internet, and hopefully that solved this, but it's been a particular problem at home all the time. So now with these minus and dot, we are going to do a slash dot. See, here it is. You can do a combination of all of these. I'm not going to continue more with this because it becomes boring, but it's an example of how you can do lines. You can combine all of these. You can combine the color, the thickness of the line, the length of the dashes, if they are dash and dots, and even more complicated things like annotated lines. Annotated lines is what allows to do this one here with the tiles and the text, a bit harder, and even these ones that are lines, but they simulate, they are circles. And these ones are two types of lines that you have circles of different types. So combining all of these things, you can make lines with a very particular line styles if you need, for example, to distinguish them in a plot that XY plot that has many lines that you make them different. Colors are many times not so easy to see when you have more than 3 or 4. So this is about plotting lines. Now, let's see symbols. Symbols are similar to lines, except that we don't need two points. We need only 1 point, and it's the coordinates of the symbol. So we're going to start a new script. And you do Control or Command N, and you start a new script, and you copy the line, the first line. This is not lines, it's symbols. GMT and then we're going to start to plot just a circle. I have here prepared. You have on the GitHub page, those scripts are there where I'm picking the commands one by one. So symbols. I also need the coordinates, and I'm going to use this construction. So, okay, it's nice. Just let me copy this one here. Okay, what does this do? Echo, it repeats these two numbers. And you are going to use the pipe operator, which is a vertical bar. It means that the output of this command, which is the coordinates, 0, 0, are going to be sent directly to the plot command that it will plot the symbol. Then again, we have to specify the region. We could have specified at the beginning. The region, also the dimensions, again, linear, we are doing linear, 15 by 15, or could have just have 15, or put the units here. Similar, we have the axis, and we're going to add a title to our plot. You add the title with the +T option, and then you type here whatever you want for a title. When the titles have spaces, we have to enclose them in quotes. And we're going to paint the symbol with green. We use the -G option. That is what is needed to paint the symbol. And you have to specify also the size, the symbol and the size. The symbol here, C, stands for circle. And then you say the size, which is in fact, in this case, the diameter of the circle. So this one will be 0.75 centimeters, what's the C here. But I have to give a name to the script. They're going to be symbols. GMT, not overlap the other one. And again, sorry, just let me close these ones, because on Windows it keeps opening new ones, it does not update. And then confirm ls star. So I have it here, bash symbols D and oh no, I know I made a small, not exactly mistake, but I forgot to add the show command. So it did run because this is very quick, but did not show the result. So I have to add it to see the result. Okay, here it is. We have a green circle without any outline. So you can add outlines. What is the outline? You can, or does not have an outline. So if you want to have an outline in the circle or in the symbol, whatever the symbol is, you need to add one. That's what we're going to do on the next symbol. What's this? Less. So repeat, similar, but we add the one cut too much. So now we're going to say that we want an outline. The outline is again the -W option, and it works the same way. One is 1 point, so we can add the point and say it's like same size. All the rest is similar. We don't give anymore the B and the title and the projection and the region because they are already set, and we run it. This window. So yeah. So again, so I can combine what we did before with the lines for the outline of the symbols, because what we are doing is actually plotting a line around the symbol. So I can put it dash, dash dot, change the color, and so forth. That's what is used to get any of these. Make it a bit quicker. So symbol, don't remember exactly, it's the line thickness that is small. We have a dashed line, we have a dash dots, and you have a circle that is not filled. This is for circles. You can plot also other symbols. This is a star. Okay. Plot, the main page for plot explains all of these symbols and the codes that we use it. Because it do a lot, that main page is a bit, well, you have to read it with some attention because there are many options. And one of them is the symbols, and you can have many symbols. So the main page is a bit long. All of these are the classical symbols that we have in the other plotting programs. Star is an A, this is a diamond is a D, this is an hexagon is a D for the code, this is a plus, this is a square, and so forth. Other than these symbols, we have also some other types of symbols, which are the custom symbols. So GMT is a collection of custom symbols that we can use to plot them. For example, these ones here, this array, this one is a hurricane, is the Pac-Man, the sun, a volcano, all of that, and those are predefined in GMT. So let's do one or two of them. And skip some of the other ones and symbols. Okay. Starting, for example, this one, the flash. Copy the line with the flash and explain it. So it's similar to the rest. You say the color, you put the outline thickness, and then for the custom symbols, the code is K. You always do this -SK, small k, and then comes the name of the symbol. This one is flash. The GitHub page has a link to a figure with the symbols and their names. We do the similar, then you do slash and the size of the symbol. So if you do these and run, and you can get the new one, and so forth. Other symbols that are you get them just by tapping the names. That's what we see. So you have them all of here. The last one is called volcano. So to plot them, you just give different coordinates, a different name, and again, I type it, different names, and you get these. Still, another type of symbols are those on top. Those are not symbols that come off GMT. Those are, in fact, PostScript images that we can also use in plot as symbols. So the rooster and the sardine are those that we have stored in the GMT server, so we can use them. But otherwise, if you want to do this could be a picture, could be anything. It could be just a PostScript image that you use as a symbol. And you can plot them as you are plotting symbols, circles or stars or squares. You plot other images, including pictures, whatever you want. But you need to have these prepared as encapsulated PostScript images. That's what we get. That's what we have. Where is it? So I'm going to show one of them. One of them is at the end. This one. And I'm going to use this one here. See, the syntax is very similar, and it could be almost equal. Gallo is the name of the file, and you have the @ symbol before the name of the file. The @ symbol is a mechanism that we have in GMT that downloads files that we have stored in GMT server. You will see next when Leo gonna show you how to make images with the TTM models grids. We'll download the grids directly from the server, and you do that by prefacing with the @ symbol. Okay, this only works if that file is stored there. You cannot just type this @ and then some other name, because if the file does not exist, of course, it cannot be downloaded. But for those that are there, and this is one of them, you can use them as a symbol. So syntax is the same, K, and then the name. If this is a name of encapsulated PostScript file, you can use them as a symbol, and that's what we're gonna do. Downloading, see, downloading. By the way, it's always downloading the file. If I do it again, it will download it again. It should, this is a little feature. You should store it locally on our computers. The idea is when you do this, he only downloads the first time, then he puts you on the cache file on your home directory. But this one is downloading every time you run it. So you see, now you have it here. Of course, it depends if you have a file, and that file is not so easy to prepare because you need to have a PostScript file that, well, it should not have white around the figure and things like that. Otherwise, it can be a very small one. But it's a very powerful mechanism that you can use to make plots, very different plots. And these ones can be, as I'm saying, can be pictures, can be whatever you want, as long as you have it, that file prepared, you use it as a symbol. I'm running a little bit because I also want to show the last part with painting polygons. And we're going to use Italy again. So going back here. Let's examples. So we're going to use Italy, but this time as an example. But this time I'm going to extract the outline of Italy to use as a polygon. So polygon that we can paint, use as an example of painting and drawing outlines. So I'm going to close this one and open another one. So the script that you have at the GitHub page has more comments. I'm not typing the commands here because I don't have time for that. So I'll just go back. This one is this line that will, and I'll use it here. Before the GMT begin. This one is, we are going to use the PS coast. Oh, should not. Yeah. Extract Italy, and the -m option will write, instead of painting, you have seen coast being used to paint polygons, to paint countries, and you use it before. But if you use the -m, it means instead of making a figure, you will just output the coordinates of whatever country you selected. And because of some other reason that I don't have so present right now, because the islands, I only want the main continent, and I selected on the polygon that have more points. And I'm saving it as a binary file. How do I do that? By using this small case -b, it means write the file in binary. And O is for output, and F is for saving it floats of 4 bytes. And then the redirect to the file name, italy.bin, and we will have a polygon that is the border of Italy, the main continent, not in the country, and in binary. I'm using binary to make it quicker to draw, because it has a lot of points. So I don't remember if here we could use just coast. I'm not sure, because it's outside the script that starts the modern mode, which is the GMT begin. I could try it, but I'm not, don't remember right now if I could here just add GMT coast, because GMT is a bit picky. When you are in modern mode, you have to call it the modern names, and outside of it, it does not remember. So, here. No symbols, this one. No. So here I have the coordinates of the Italia already. Before Paul showed you that you could have used -r, it, and some coordinates, but in this case I already have them. So I'm using the coordinates that are appropriate for this map. Again, this time I'm using the Mercator projection, make a plot with 15 centimeters wide, and tell it to use to annotate and plot things, and make the outline 1 point thick. 1 point, and here we're going to use another thing that you can do with GMT is patterns. Patterns, we have a list of 80 or 90 different patterns. Again, the GitHub page has a link to the table that shows you the name of the patterns and small images that show what those patterns are. So I'm using the one that they don't have names, they have numbers. So this one is the pattern number 32. And I'm saying this, the density is 100 dpi's and the color is blue. So the effect of this is we save it as, so it's another Italia, just Italia. Again, and I bash Italia. Yes. So it looks similar to what Paul has showed you before, but there is difference. This one is not from, it was extracted from the database of the countries, but it's just a polygon that happens to be the polygon with the border of Italy. And see, instead of painting it with a color, I painted it with a pattern. And we have outlined this black line with 1 point thickness. 5. I don't think I have much more time because I want you to, well, I need time to at least one more, to put a symbol. No, not this one. So because this is a plot with lines, we can plot lines. Polygons are lines that are closed. And we're going to use also the symbol that we used before, the custom symbol, which is Mecha from mechanism, from earthquakes, also known as beach balls, and is going to be painted with a shade gray of 100 and with an outline, or a very thin outline. So this is, yeah, we run, and here we have it. Okay. I have to stop here because I would like you to try to do something, some variation around this last figure. For example, changing the colors, changing the line thickness, changing the line style, and create plots with these. You have also a script with a solution that we can look later, or can you look before, but I would like you now to try to make maps like these, but changing these aspects. You have on the GitHub page, no, this one. I see lots of message, don't know what you are asking. So, oh, yes, it was updated. So if you had time, probably you have not much time to do all of these, but yeah, it was not updated. The instructions with sorry, should have been. So I had in the list here the tasks that you should do, but the tasks are do these with different colors, different line styles, and I also wanted that you changed symbols, and even if you could make a plot with different symbols at these positions. But don't know what happened, it was not updated. So okay, I will stop here, and we'll leave you with some time to try to do some of them.
Great, thanks, Joachim. So Melissa, we shall break into breakout groups again, and then the instructors can answer questions in Slack.
Okay. Hopefully that works. All right, so welcome back. I guess we'll get started. I can't really tell if everyone's back on the participant list, but I guess almost everyone's here. All right, so now you've seen how to do some basic plots in GMT with drawing the coastlines, some not so basic plots with custom symbols and clipping polygons, etc. And now for this part, we're going to look at how we plot gridded data. So how do we make images of Earth relief or gravity fields or the INSAR displacements and interferograms, that sort of stuff, right? Right, so the link to the notes that I'm going to be following here was posted on the Slack, so you can follow along through there as well if you want. Right, so now we're going to look at how we represent grids in GMT. So mostly the main format, but GMT does support other types of grids. Then we're going to look at how we plot contours of those grids. Then also how do we make pseudo color images like this one. And then we're going to go for a group exercise at the end in the breakout rooms, right? Right, so the main file format that GMT uses for grids is called netcdf. So netcdf is according to Wikipedia, it's a self-describing machine-independent data format to support the creation and access and sharing of array-oriented scientific data. Right, so that's a lot of mumbo jumbo to say that that netcdf is a binary file. So it's not going to be a text file that you can open in VS Code. And it's going to have the data values on a grid, the coordinates that accompany those data values, and a lot of metadata as well, right? So things like the units, the projections, which programs were used to create this, etc. And that's what they mean when they say self-describing, is that everything you need is within that one single file. Right, so GMT takes advantage of this. So it's fairly easy for GMT to guess the coordinates and everything else from a single gridded file. Right, so you can read further about all this. So within the notes here, there's often a further reading link. So this is where you would go in the GMT documentation to get more information about this and dig deeper into these resources. All right, so now let's do a little bit of a practical thing. So all GMT commands that work on grids, they start with the letters GRD. Right, so anything that starts with GRD in GMT, it's gonna either input or output a grid, right? Usually input a grid, right? So it's fairly easy to find these in the documentation. If you go to the modules page, then you can look for the GRD modules, and you'll find almost everything you need in there. And there's quite a bit of stuff. Here, we're only going to cover the plotting, but as Paul said, there's a lot of data processing as well that can be done with GMT. All right, so throughout the section, we're going to be using the built-in Earth relief grids for GMT. So if you also go to the link, you can read all about these grids, but basically GMT serves a whole bunch of gridded topography. And these are all stored in the GMT server. For now, everything is in Hawaii with Paul, but we're looking to distribute those across the world. And what GMT lets you do is with a single command, you can download all these files to your computer and use them in the plotting without having to go and search for the data set and everything else, right? So the first command we're going to look at is called GRD info, and this is used to get information out of this netcdf file. Right, so how do I figure out, how do I read all the metadata and everything else? All right, so I'm going to hop on over here to VS Code, and hopefully everyone can see. And I have my terminal open here in the bottom of VS Code. If you're on Windows, or if you want, you can open the terminal app on Mac or Linux, or you can open Git Bash if you're on Windows and follow along. All right, so if I want to get information about the 10 arc-minute Earth relief grids that GMT serves, the command that I'm going to type is GMT space GRD info, and then space. Then I'm going to give it the name of the file. So since this is a special file name that GMT knows how to download it, it always starts with an @ right? So this is like Joaquim's Gallo image. The @ file names are files that GMT knows how to download them to your computer. So I'm going to say @earth_relief_, and then I have to say the resolution that I want, or the size of the pixels. And in my case, I'm going to do 10 and M for arc minute. So if I type that, hopefully if you did the homework that was sent in the email, you shouldn't get a downloading message. Otherwise, you might get a message saying downloading Earth relief data from GMT server something Oceania. But for most of you, you should get an output very similar to what I have here. So what is this saying, right? So the first thing in the line here should be where the file is located. And in my case, it's in my home directory in a .gmt folder, and then in a folder called server, earth relief 10mp.grd. So this is the file that GMT downloaded automatically, and it knows where to find it on my computer afterwards. So the metadata that we get for this says that the title here is Earth Relief 10 arc minutes. One nice thing about GMT is that we really endeavor to include the full command that generated this file, right? So if you ever want to know where this Earth Relief data came from, what sort of filtering was applied to it, that all of that is encapsulated in this line, right? So this is how it was, where it came from. So this is from Brooks SRTM 15 plus grid, and it was created by filtering and downsampling the grid. Another thing that you might note is that it says pixel node registration. So I'm probably not going to have time to go into grid registration, but there's a little section in that the GitHub link where you can read more about this, and it links to the GMT documentation on this as well. And another thing that it says is that this is netcdf4 format, right? So we know that this is a netcdf grid, and you'll often come across netcdf grids when you're dealing with Earth imagery or climate models or potential field data, that sort of thing. Right, so that's fairly common. Okay, so right, so the GRD info basically gives us that information. Another thing we can do is if we type GMT GRD info at Earth Relief 10M, GRD info has a lot of options. One of them is -C N. And what this does is instead of giving us all the metadata, it just gives us some numbers that are numerical information about the grid. So in this case, the format is the west, east, south, north boundaries of the grid. And it also gives us the minimum and maximum data values, the grid spacing in X and Y, the number of points in X and Y, and the, I forget what 1 and 1 are. Right, but you can check the documentation about what that is. And as you can see, like even the ones who use this regularly don't always remember everything. So that's why the docs are really good. Right, so if you need to get these informations and use them in your script for using, for example, the grid spacing, there are ways that you can get just the grid spacing, for example, and use that in a bash variable, as Paul showed in the beginning. And also that's on the GitHub page as well, if you want to have a look. All right, but moving on. So let's get to the actual interesting stuff. So now we know where what the grids in GMT sort of look like, and we know how to get some basic information out of those grids, but how do we plot them, right? How do we make a nice map out of it? So going back here to my notes, sorry, I forgot to mention, in the notes here, there's a lot of bonus sections. So these you can go back and read when you have more time or when you're trying to do the exercise. If you need a little bit more information, then these have somewhat hints for more advanced things that you could do. Right, so let's get to the plotting, right? So the first thing we're gonna try to do is make some contour plots. And so in contour plots, oh, I see some people are getting errors downloading the data. So that might happen. That's why we gave you the homework before, so that we could try to guarantee that you have the data already. If you're having trouble with the network, try doing a lower resolution grid. So instead of 10M, you could say, for example, 01D for a 1 degree grid. That's the lowest resolution we have, and it should be the smallest file as well. Right, so getting back to the plotting, the first kind of plotting we're going to do is for contours, right? So contours would be contour lines that are represent a single value, for example, in the grid. So that's very common when plotting topography, and it's also a good way to plot on top of the pseudo-color images. It can be a little bit easier to read, right? Oh, okay. So I see a lot of people are getting trouble, but let's move along and we'll try to sort that out in the chat. All right, so the command that we're going to use to make contours in GMT. So since it makes contours from grids, it's going to start with GRD. And since it makes contours, the command is GRD contour, right? And you can go look at the docs for that. There are a lot of options to all of these commands because GMT can be tweaked almost infinitely. So you can make the plot look any way you like, and you can configure it beyond the defaults to make some very, very nice figures. Here, we're going to stick to the defaults, and we're going to show one or two configuration options, but we really encourage you to go to the documentation and read it and try to, you can ask questions as well on the forum if you're having trouble, to really explore the tools and see what's available. All right, so first thing we're going to try to do is let's try to make a contour map of the world of world topography, right? Our 10M topography. Right, so let's go back here to VS Code. And all right, so as we did before, we're going to create a new script. So I'm going to create here a new file, and I am going to call it, contour world.sh. All right, so I have contour-world.sh. And as always with all our scripts, let's start with #! /bin/bash or /user/env/bin/env bash, whichever one you prefer. It doesn't really make a huge difference. All right, so let's comment out our script just so that it looks nice. And what we're going to say is contour plot of the world topography using the defaults. All right, so since this is a GMT modern mode script, we always start with GMT begin, and then we're going to give our figure a name. I'm going to call mine contour-world, just so that it's the same as the script, and that makes it a little bit easier. And we're going to finish with GMT end show. Right, and I'm just going to use the default, but you can do PNG or you could do PDF, whichever you prefer. All right, so first command we're going to do, same thing that Paul was doing a lot, is do GMT base map to set the region, the projection, and the frame. Right, so for the region, we're going to do global. So let's make a map of the entire world. And as you might recall, we can do -RG as a shortcut for global topography, for a global region. We could also do -180 to 180 or 0 to 360 if you want to be more explicit, but -RG works nice. All right, so for projection, let's do a Mulvide plot because I like that projection. So let's do W and let's have it at 0. And let's do the size of the figure, let's say 15 centimeters, so 15 C. And for the borders, I'm going to say -B AF, right, for automatic annotations and automatic frame. Okay, so now I have my base map, and if I want to plot my Earth relief data, remember the command is GRD contour. And with a lot of these commands that take input, unlike Coast, where it knows where to find the coastline data sets, for a lot of the other plottings, we need to give it some input, like you did with GMT plot with Joachim earlier. The way we give inputs to GRD contour is by specifying the file name. So in our case, we're going to use the special file at Earth relief 10M. Or you could go coarser if you're having trouble. And we're just going to do the defaults, right? So I'm not going to give it anything else. All right, so now that we have that, I'm going to finish with that, and I'm going to save. And I'm going to go into my terminal here, and I'm going to type bash, and then the name of my script, which is Oh, where was this saved actually? Oh, apologies. This was saved in the wrong place. Okay, so now it should work. Okay, so contour world. So bash contour world. This should be work, and hopefully this will work, and I'm not going to embarrass myself. All right, so now we have a contour plot of the world. Now it doesn't look particularly nice because we're using defaults. So there's only so much that GMT can do to make things look nicely without really knowing much. All right, so in this case, there's way too many contours. The fonts are too big, but we can configure a lot of that. Okay. All right, so right, so what I'm gonna do now is let's, instead of just doing the whole world, let's focus on a smaller part. So I'm gonna make a new file here, new file, and I'm gonna call it contour.sh. Right, so instead of doing a whole big global contour map, let's just focus on Antarctica, and then we can look at another projection that also looks nicely. So again, same thing. So hash exclamation /bin/bash. Then let's give it a little comment saying contour map of Antarctica. And as always, GMT begin. And I'm going to call this, let's call it Antarctica. And GMT end show. All right, so again, same as always, GMT base map -r. And if we look up the country code for Antarctica, so if you Google country code Antarctica, or if you go to the Wikipedia page, you'll see that Antarctica is a Q. Right, so for the projection this time, you can look up the GMT page for projections. There's links to that on the GitHub as well. And one projection that we can use nicely for the South Pole is a stereographic projection that's centered on the South Pole. So the letter code for stereographic projection is uppercase S, and we have to tell it the center of the projection. So in this case, it's going to be 0 longitude, or if it's at the pole, doesn't really matter the longitude. And then we want the South Pole, so -90 for latitude, right? So this is the center of the projection. Then we also do another slash, and we have to give it the size of the plot. So let's do 15 centimeters again. And let's do -BAF as well. All right, so now we have our base map, and now let's do GMT GRD contour at Earth relief 10M. And if I save this and I run it, I should see again our default color map, contour plot. So bash contour.sh, and I should get now a contour plot of Antarctica, which looks a little bit better, right? So this is a little bit more legible, but it's still a little bit too busy. The font is a little bit too large, and this really needs some configuration. So let's look at how we can configure this a little bit. Right, so I'm going to close my plot here. Right, so this was all using the defaults for GRD contour. So let's look at some of the options that we can give it, right? So one of the options we can use is -C, and -C sets the interval for the contours that don't have annotations. So if you notice from the previous plot, some of the contours have numbers on them and some don't. So -C sets the interval for the ones that don't have annotations. Right, so let's say instead of having the default, let's say contours every 1,000 meters in this case, or every 1 kilometer. Another command we can give it is -a, which sets the interval for the annotated contours. And this has to be a multiple of the minus c value. So let's say every 2,000 meters, then we have an annotated contour. So we're going to have alternating not annotated, annotated contours. So we're reducing the number of contours. Hopefully that'll make the plot a little bit less busy. All right, so I'm going to save, and then I'm going to run again. And one trick, if you haven't figured this out already, if you're on a terminal, if you press up on your keyboard, it'll repeat the previous command that you entered. So that's an easy way to rerun the command over and over again. All right, so let's run again, bash contour F. Right, so now notice that we have a lot less contours. So this is a little bit more legible than it used to be. Right, but still we might want to change the size of the font of the annotations, or change the color, or the line size, or the pen attribute of the contours, right? As GMT calls it. So let's try to make these, let's try to set the color and the thickness of the contours and see if we can control that. Right. So the way to control the pen of the contours is with the -W option. And we can provide this option twice. One for the non-annotated contours, so -W lowercase c, and then we can give it the pen attributes, right? So let's say we want a thin contour, or let's say we want the thinnest contour available, and we want to plot it in red, for example, right? And we can also do -WA for the annotated contour pen. And let's make this a little bit thicker. So let's make it just thin instead of the thinnest. And we can have this in black, right? So let's save, and let's run our script again. Right, so now you see that we could control the thickness and the color of the contours. And the color names that we can put here, let me break this up. The color names that you can specify here can be any of those hundreds of color names that GMT supports, or you can use RGB codes or CMYK and all the color attributions that GMT supports. Right, so you can really go nuts with the contours and make them look however you want them to look, and depending on your aesthetic sense or how well you want, or what you want to do with your map, right? Okay, so let me check the time. Okay, so that's it for the contours. So you really go look at the contour documentation. There's a lot that you can do with the contours. I do provide some more examples of customization on the GitHub website, but you can check things there. All right, so next up is pseudo color plots. So how do we make image plots with GMT? And one thing that you might guess is that the command for this is going to start with GRD. And since we're plotting something that looks like an image, the command is called GRD image. And again, the defaults provide you with quite a bit, but there's a lot of configuration that you can apply to these plots to make them look as nice as you want them. Right, so a pseudo color plot, when you're plotting this type of data set from a grid, we need to map the data value to a color somehow. And the terminology for that in GMT is called a color palette table, right? So this is a table that maps the data values to a color value, right? To a specific color. And GMT, so in GMT, they're called CPTs. In MATLAB or Python, they're usually called color maps. But they're basically the same thing. But the GMT CPT has some other nice features that the other ones usually don't have. Right, so GMT has many CPTs available. You can check out the link here, and there's a list of all of them with a sample of the color bar, so you can choose visually which CPT represents the data that you want to use. And of course, there's links here for further reading, because there's a lot that you can dive into to learn about GRD image and CPTs in general in GMT. All right, so let's go back to our Visual Studio Code, and this time we want to make a pseudo color map of Antarctica, and let's see how to do that with GRD image. All right, so I'm back in VS Code. I'm gonna do Control N for creating a new file, and let's call this one image.sh. All right, so I have my image.sh file, and I'm gonna start it exactly the same way. So hash, this is usually pronounced shebang. So shebang /bin/bash. And this is gonna be a image plot of Antarctica topography. All right, so again, let's start with the basics, with the defaults first, and then we'll customize it slowly. So GMT begin, and let's call this Antarctica image. Lowercase it. There we go. GMT and show. And by the way, the show here is optional. If you don't want the map to appear on your screen when you run the script, you can omit the show and it'll just be saved to the file. But this is useful if you're writing a script and you want to see your plot every single time. It's better than having to open it separately over and over again. All right, so let's be lazy and let's go back to our contour map, and I'm going to copy the same base map line. So GMT base map minus RAQ, all of this is going to be exactly the same. And the new command now is going to be GMT GRD image. And as you might have guessed, we need to specify the file that we want to plot. So in our case, it's our special file at Earth Relief 10M. And if you already have an .etcdf file that's a data set that you want to plot, this is where you would, without the @ symbol, this is where you would put the name of the file or the path to the file that you want to plot. Right, so let's look at what GMT can do by default. So I'm going to save this and I'm going to run bash image.sh in my terminal. And let's see what GMT can do by default. All right, so by default, GMT recognizes that it's plotting Earth relief, and it chooses a color map that is used usually for plotting Earth relief. Right, so it can be a little bit smart like that. Otherwise, the default map is probably going to be a rainbow color map. But you can choose different ones, and we'll go over how to do that in a little while. So right, so I have my image map of Antarctica. The problem is that I don't know what the colors mean. And to do that, we need to plot a color bar as well. Right, so the little bar that has the colors mapped to particular values. So the command to do that in GMT, as you might have guessed, is GMT color bar. And again, let's just see what GMT can do by default. And to be clear, a lot of these defaults, they really didn't work prior to GMT 6. So this is all relatively new developments. So for those of you who are coming from GMT 4 or 5, you'll notice that there's a lot less code that you need to write just to get a basic plot going. Right, so let's run it again. So bash image.sh. And now by default, GMT will put a color bar here in the bottom, and it's nicely placed. It's not overlapping with the figure, and we can control the placement, but we'll see how to do that in a little while. So now we have our basic pseudo color map, pseudo color image plotted here. So let's look at some of the other configurations that we can do to make this look even nicer. All right, so one thing we can do to improve it is to use something called hill shading. So this is where we we add a shading effect to the image as if there were sunlight shining on it from a certain direction. Right, so this is very common in this type of imagery because it can make, or a particular topography, it can make the hills and valleys a little bit easier to see. So the way we do that in GMT is in GRD image. You can add the shading with option -I, right? And -I usually will take another grid file, but for now we're going to use the default. So if we say I plus D for the default configuration, this is going to apply shading with the default parameters. So let's see what that looks like. Let's save and run bash image. All right, so now there's a little bit of shading that's been applied to the image. With this particular color map, what it does is it makes the ice here look dirty, because the colors for lower altitudes are brownish. So it doesn't look particularly nice on this example, but let's try with a different color map and see if it looks a little better. Right, so if I want to use a different CPT for my GRD image plot, the option that I'm going to use is -C for adding a color bar. So a color bar, no, for adding, specifying the CPT. And the CPT that I want to use now is called gray, right? So let's use only shades of gray, and that will really make the shadows pop out a little bit more. So let's save this and run bash image. All right, so now our image is in grayscale, and you'll notice that the color bar updates automatically as we would expect. And here we can see the shading effect a little bit better. For example, around here, we can see that the inner border has shading on the inside as well. If you look at the options for -I, you can actually specify the direction in which you want the light to come in, and you can specify the intensity of the light and the angle as well. So there's a lot of configuration that can go, and you can make some very nice figures with this. All right, so moving on from there, there's a bonus here as well for using the option -D in GMT color bar to place the color bar in a different place. Right, so you can control the placing of the color bar, and you can look into that on your own time later. All right, so how long do we have left? I think 20 minutes, right? Right, so let's go for a group exercise that you can try to do. Right, so this is how that's going to work. We're going to split you into the breakout groups again. And what I really want you to try to do is first unmute, turn on your camera, say hi to everyone, try to get to know each other a little bit. And then I want you to try to work as a group to make a map. So discuss which commands you would use, which options you would use to make it, and then try to, as a group, try to make a really nice looking map with the time that you have left. And before we break for the day, we'll bring you back, and I'll share the code for the map that I make that I made, and we'll do a little wrap up of the whole day, right? So you'll be split into breakout rooms. So your task for today is to make a relief map of a country of your choice. So pick a country amongst yourselves. It could be one that you live in, or it could be just one that you like the topographical features of it. For example, Turkey has some really nice topography. So pick a country, choose the ISO code, choose a projection from the list of GMT projections. Then I want you to make a hill shaded pseudo-color map of Earth relief, and you can choose whichever CPT you want. I encourage you to go to the GMT documentation, find a nice CPT, and discuss amongst yourselves which CPT would be best. Then overlay contours on the plot. So also put in some contours in your plot to make it a little bit easier to read, and also add a color bar. So for bonus points, if you finish early, try putting a little note on the color bar, a label on the color bar indicating the units, and try to add a title to your plot as well. So if you're finished early, there's some extra challenges there for you. So ideally, the map you make should look something like this, right? So this is a relief map of my home country of Brazil. And this was created with the commands that I showed you already. So you have all the tools you need to make a map pretty much exactly like this. So go ahead and try, and we'll be in the Slack chat room. I'm not gonna have the video on, but we'll be on Slack to try to help you out. And we'll see you back in 10 minutes, 15 minutes. Is that how long I have left?
Yeah, something like that. It can go long too. So we're in the wrap-up session. So we realized that we leave a lot of stuff on the table. It's just way too complicated to cover everything, explain everything. We can get off on tangents and look at different options to different modules that we never explained. We didn't do a great job of introducing the documentation and how to understand documentation. So we have to, we're taking notes as we go along. We realize we can do things better, but we're also interested in your perspectives. So in the Google Docs document that I created, that you all have a link to from the GitHub front page, it's called Comments, Student Comments. Please be brutally honest with anything that you liked or didn't like, because as I said, this is the very first time we're trying this. And scaling it up from 25 people to 80 and not having anything in room and cutting the time by 40%. Well, it's a lot of challenges, put it that way. And so we're doing the best we can, but we have very thick skin and we can take very harsh criticism. It's not a problem. This is a learning thing for everybody. So the other thing I want to say is that of course, we didn't finish every project and we didn't answer every possible question. Remember that even after this workshop is completely ended, the GMT forum will live on. And if you have questions that didn't get answered, you can post them on the forum and someone will answer. It may not be us, but it might be us. It might be one of you or some other GMT user. And if there's a more serious problem, like you actually found a bug, we will probably ask you to post it on the GitHub site. It's okay to start on the forum if you're not quite sure if it's a bug, because very often it could be a user error, or it could just be bad documentation, or sometimes there's bugs. So we'll direct you to open an issue on GitHub, and then we can really zoom in and track it and work through it until it's solved. And we had a couple of issues today that we noticed is probably a bug. We usually call them features when they're sort of not too bad bugs, but it's the same thing. It doesn't quite work the way you expected. And that's the GMT life. We find problems all the time and we fix them, and there's never an end to that, actually. So we appreciate any comments you have back on things that didn't work or things that can be done better. So we are recording all this stuff. The recordings will be up. You can always go back and revisit this entire day. And if you missed anything, and hopefully the recordings are nice and crisp and you can see everything. The scripts we made will be online. Some of them are already online, the one before we did things. And they're sort of meant to give you an idea of how we did things live. It may not be verbatim the same scripts, but it's the same kind of task that we set out to do. See what else. Anything I forgot to say, Leo or Joachim or Dang, Eric?
Yeah, that's mostly it. And I would say, like, we look forward to seeing you all in the GMT forum. There's a thread in there that's just to pop in and say hi and introduce yourself. So also feel free to use that, or keep using the Slack chat room. You can talk amongst ourselves or keep asking us questions, though we are spread across very, very broad range of time zones.
Yes, exactly. So the breakout rooms, the way it sort of almost have to work is that the people you end up with, you have to help each other more than rely on one of us being in the breakout room, because we have a hard time controlling exactly how those rooms are set up. So take pity on your fellow travelers inside the breakout room and try to get to know them a little bit, and just come up with common solutions to common problems. And then obviously post questions on the Slack channel, and we will address them as best as we can. We have 7 pair of eyes looking at the Slack all the time, and we all jump on them. So we try to be as responsive as we can. And it's so far, I think we managed to at least try to attempt to answer everything. So it's about noontime in Hawaii. It's time for lunch. I know it's a little bit different time zones out there, so there's people who probably want to go to bed. And then it's all repeating tomorrow morning or night, depending. We'll be back here at the same time, same everything, and to discuss things that get a little bit more specific to geodesy. We'll look at seismology and beach balls, that sort of thing, and GPS and vector symbols and that sort of thing. And then we'll do a little bit of how to make an animation, make a video, and then we'll have a group project or a project that sort of ties things together. It'll be very individualized, but again, we'll have to push this into the breakout rooms. So you will need the help from your fellow participants. And then we'll sort of meet at the end of the day and talk about some of the projects, hopefully, and also where to go next. So with that, I wish you a happy day, happy night, whatever time zone you're in, and we will see you tomorrow morning. Or again,
just before we popped out, sorry, one last thing. So since we have the project tomorrow, if you can maybe start thinking about something that you would like to do within an hour involving GMT and Geodesy. If you met anyone else during the course that maybe wants to collaborate, it might be a good time to start chatting about that today or tomorrow, and then you could be all set for the project.
Yes, and since we are not going to be providing any seismology or geodesy data sets, if you have data sets for your area that you're interested in plotting in GMT, that's usually a good project for the final project. Try to make a map that shows, let's say, GPS stations in your country or some seismicity the last 2 years in your region or something like that. That's usually a good project to try if you haven't done a whole lot of GMT before. So think about that and get organized the data files if you want to use them. Because again, the time is very short once we start, and we can't help you finding files and data sets. Okay, anything else, guys? All right, then we will see you tomorrow. Get some food, sleep, beer, whatever you need, and then we'll see you in, what is that, 19 hours. Stay healthy. Signing off.
Thanks, see you everyone.
See you tomorrow.
Thank you.
Good night.
Good night.